Hi there.
Hello
How are
there.
you?
We're starting the webinar. Good morning, good afternoon, good evening to everyone. Welcome to the last Ocean Exchange webcast for 2020. That hardly seems possible. We have more exciting things planned for 2021, and I'll get to that later. Happy holidays, Merry Christmas, Happy New Year, happy to everyone. And we hope that you're all safe wherever you are. Ocean Exchange is a nonprofit. We exist solely to help advance the adoption of innovative solutions that are for healthy oceans and the environment. We have some particular interest in sustainable shipping as well. You see here our major sponsors. You can find the rest of them at oceanexchange.org, and we encourage you to go there. Our largest sponsor is going to be with us today from Wallenius Wilhelmsen, but we'll get to those introductions in just a moment. I want to thank Alice Spillman. She's drives the bus behind the scenes here, and she's a great asset to Ocean Exchange. Dane, why don't you take it now from here?
Thanks, Millie. Hi, everybody. We've got some really interesting things going on today. You know, if any of you are familiar with the comedian Mark Maron, he's got a little routine that he does. He did it in the middle of the year when California was on fire so terribly and everything was going. And it's somebody who just doesn't understand. He said, you know, I don't get it. I take my own bags to the supermarket. Why isn't it working? Look, recycling and all the things that we do to try to contribute to getting to zero emissions is not enough. We need better thinking. Last week, President-elect Biden announced that we need to plan on getting to net zero by 2025. That's only 29 years from now. But the way things are going with the fires last year in Australia, the fires this year in California, the way weather is changing, we need to move faster. Today, we've got two companies that are really involved in serious revolutionary thinking. One of them, Wallenius Wilhelmsen, is actually going to have a car carrier ship powered by wind that will be working the ocean by 2024. The other, Nicholas Flanders with Opus 12, they're taking recycling to a level that I think if you're not familiar with your work, you're going to find this one of the most amazing we've ever done. So let's go to the next slide. What we're going to do today is talk to Roger. Roger's going to talk about what they're doing. And then I'll come back and introduce Nicholas. And then we're going to have an interview. If you would, put your questions in the Q&A box, not in chat. I'll monitor the questions, make sure everybody gets covered. And then finally, if we have questions that are either way too technical, what we do is we wait till after the program is over. And if you want to stay around, we'll have a little extra discussion about those and dive in a little deeper, if that sounds good. So let's go to the next slide, Alice. Roger is a key part of Ocean Exchange. They're on the board. Wallenius Wilhelmsen has been a major contributor to them over the years. And Roger and I have become good friends. One thing I think is really fun, and I tell this to people at Ocean Exchange, you don't have to win the prize to come out a winner. I have seen many times someone who didn't win the Orcel Award, which is the one that Wallenius Wilhelmsen supports. But I've seen them a finalist over in a corner, and Roger's talking to them, other people from Wallenius are talking to them and saying, you know, tell us about what you're doing and how we can do it. And I've seen people fly to Norway and to have serious discussions about their thing. So there's a lot of ways to win at Ocean Exchange if you've got a great idea. So with that, let me hand over to you, Roger, and then I'll come back and introduce Nicholas.
Thank you very much, Dane, and good morning, good afternoon, good evening, everybody. It's a real pleasure to be here. I'd like to start you off with one number. That number is 5 million, and that's 5 million tons. It's the size of the challenge that we have in terms of CO2. It's the annual CO2 emissions from our fleet. We would rather that was zero because the way we look at it, those emissions, any emissions, are bad for business. So what I'm going to do is I'm just going to take you quickly through the kind of journey that we're on, and I'm going to look at some of the upsides of driving down emissions, because we tend to hear a lot about the push, but there's a big pull part of it as well. So next slide, please, Alice. Now, as an industry, we are no stranger to change. We started off 155 years ago with a sail-powered vessel, and as Dana has mentioned, it's quite possible that we might be heading back to the days of sail again. We have a zero-emission concept vessel. It was one of I think the first of its kind back in 2005. We're quite confident that that exact vessel won't be built, but it gives us something to drive or sail towards, I suppose would be the more appropriate word. And this need for us to drive down emissions is, well, it comes from a number of different things. There's a huge regulatory focus on it, but in addition, we see that our financial and commercial stakeholders, their expectations on emissions reduction are coming down, driving down fast. And it's interesting there because shipping is an indispensable global industry, but it's also a smokestack industry. And in the 21st century, that can't be a thing. So it really, presents us with a challenge. And that challenge includes when it comes to attracting talent. People care about the kind of business that they're in. They want a sense of purpose. And that's another reason for us to want to reduce. So next slide, please. Now, when we think about driving down our emissions, one of the immediate upsides of that is it helps reduce regulatory impact, which is the biggest probably change driver our business is going to see in the years ahead, or certainly one of them. In other words, it's good for future proofing. Also, with new technological solutions, which make environmental and economic sense, or lean green as we call them, that can make your operations more efficient. And that's basically the basis of how we compete today. Now, we are into a situation of the law of diminishing returns. We're already at a very efficient basis for the fuel systems we use today. However, the transition to zero emission technologies, that's going to be a huge game changer. If we can do that better than our competitors, it presents us a once in a generation opportunity to grow market share as well. And like I said, at the end of all of this, despite all of the uncertainty and all of the unknowns, there will still be shipping. It's an indispensable industry. So it's really, comes down to what's your plan, what's your approach. If we could move to the next slide then, please. For us, there are a few key elements of our approach. We're willing to take the initiative. It's not okay for us just to sit back and see what others do and take a leisurely approach. Time is not on our side, so we need to engage with trying new technologies, and we do this a lot. There are, I think, far too many to mention here, but they include technologies that we've discovered at the Ocean Exchange and which are now become a mainstream part of how we operate our fleet efficiently. We're also very keen to partner because this is a challenge which is bigger than any one company. I would even say that it's bigger than any country. So the need to collaborate here at a global level and on a scale that we've not seen before is incredibly important. Ocean Exchange, that helps us in that effort as well. We need to be open-minded and we need to be curious. And we don't know what the ultimate solutions are going to be for achieving zero emissions. There's a lot of variables which we don't control in this. And so that's why it's important to remain open-minded. We also need to make sure that our need as an industry is broadcast widely. Shipping might be the original global industry, but it's also a hidden industry. It tends not to be first to mind for the world's innovators. And so we try to attract, it's another reason actually for being involved with Ocean Exchange. It's a way for us to access innovation clusters who wouldn't normally have shipping as a front of mind industry. And then we think about lean green solutions. That's also the name for our sustainability strategy. And it really, the basis of it is the idea that what is environmental and what's economically sound can and must be the same thing. And you know, there's a saying that comes to mind here, which was it's about the fastest way to become a millionaire in shipping is to start out as a billionaire and make the wrong decisions. So all of these factors, I think, help you see why Ocean Exchange has been such a valuable business proposition, as well as something which we feel contributes just to a greater good. We're open to new ideas all the time. And speaking of which, I think this will be a very good time to give the word back to you, Dane, and introduce our next speaker.
Thanks, Roger. Oh, did you want to do the Letterman? Okay.
We can, let me do that one, Dane. Sorry, that was my mistake.
Yeah.
So I was
Okay.
just talking to the point of talking about of the new solutions. And one of the things that we come across at Ocean Exchange very often is brilliant technologies, which are brilliant solutions that for problems that haven't been very well defined. And so how do we actually get greater clarity on whether a solution will float or not? And I'm reminded here of what David Letterman had as a feature for many years on his show was the will it float test. And he basically invited the audience to guess, would a particular object float or not? Well, so I'm using that as a metaphor here for will an idea work in reality? And the way that we look at it, there are 5 elements that must be satisfied for something to work in reality. It needs to make technical sense. If it's a new type of fuel, will it work with existing machinery? How do you store it on board a vessel? Questions like that. Staying with fuels as an example, from an operational perspective, you need to know that you can get the fuel in the quantities and the locations where you operate. Then there's the financial perspective. How does this compare against other solutions which are on the market or which you believe may come to the market? There's the regulatory side too. And that's not just about thinking about how does it fit vis-a-vis the current requirements, but also where the requirements go to be in 10 years or 20 years or even 30 years, because the asset play in shipping is that long. And finally, there's the point which is quite often left out, is the commercial consideration. If you adopt this technology, will it enable you to still provide a service that's competitive in the marketplace? So those are questions that we ask on a per vessel basis, whether it's a new or an existing vessel. And we also know that those can change over time. But I think if you can answer all of those positively, definitely we need to have a business discussion. Now for real, Dane, I'm handing the word back to you.
All right, thanks. Well, Opus 12 has something that I think clearly does float, and they're an interesting history with Ocean Exchange. In 2016, we started the Collegiate Award, and they were the first winner of the Collegiate Award. Nicholas brought his team from Stanford and won that award. Then we're back 3 years later in 2019 to win the Neptune Award. Tremendous technology, and I think, let me just go straight to it. Nicholas, welcome.
Thanks very much, and very happy to be here. And thanks everyone who's joined. So yes, I'm Nicholas. I'm one of the 3 co-founders at Opus 12 and the CEO. And we've developed a profitable solution to carbon emissions. So next slide. The vision is to transform CO2 into useful products. So take something that we're currently throwing away, that's the key driver of climate change, and actually recycle it back into materials and fuels. Next slide. So just a quick company history. So the 3 of us met at Stanford in grad school. My co-founders, Kendra and Atasha, were doing their PhD research in the same lab, focused on electrocatalysts for CO2 conversion. So these are materials that, by changing the size and the shape and what they're made of, you can tune what you make from CO2. So really the fundamental science behind Opus 12. And then the three of us got together at the beginning of 2016 and were selected by the Department of Energy for a new program called Cyclotron Road that we didn't have to move very far for it, but they set us up at Lawrence Berkeley National Lab, which is one of the Department of Energy research facilities around the country, to enable us to build our first prototype and basically turn what was original science into a small scale prototype. And since then, we've built the world's first low temperature CO2 electrolyzer. So I'll show you what that looks like. But the team now, we're approaching 40 people and have now started to do some customer collaborations with this CO2 conversion technology. So next slide. So one way of describing the process is industrial photosynthesis. So in the same way that a plant takes CO2, water, and energy and produces oxygen and useful carbon-based products, our process looks similar. We take CO2, water, and energy, and we produce oxygen and useful carbon-based products. But the things that we're making from CO2 are typical fuel or chemical or material building blocks, and there's no biology in what we're doing. So if you go to the next slide, you can see here that we take CO2, water, and electricity, we make oxygen, and then the first two products that we're focused on are CO. So that is used to make everything from the foam in your running shoes to the headlights of a car to jet fuel. And then the next product is ethylene, which is used to make many recyclable plastics and even ingredients in your laundry detergent. So really versatile products. These are already used today to make all of those different end applications, but today they're made from fossil fuels. And so what that means is pretty much anything that you can make from oil, we can make from CO2 and water. So if you go to the next slide. So the vision is that you could be surrounded by things made from CO2 and you wouldn't know the difference because they'd be the same products with the same properties at the same price, but with lower or even negative carbon emissions. So everything from the insulation in your wall to the fuel on the plane. So if you go to the next slide. From an ocean's perspective, our mission is to have an impact on carbon emissions, reduce the amount of warming and ocean acidification. Circular materials will keep products out of the oceans from waste streams. And then finally, we can make liquid fuels that are compatible with existing marine engines, but that would have net zero emissions. If you go to the next slide. So to show you a few examples, we have now started to collaborate with partners. So earlier this year, we unveiled the world's first car part made from CO2 in partnership with Mercedes-Benz. So our system turned CO2 into the building blocks for the interior parts. And then we worked with Mercedes' existing supplier to make the final part. So the next step here is that we'll be building a larger system that can integrate into their supplier's facility and produce enough material to make all the parts for all of a specific line that they have coming out. And then over time, make enough material for all Mercedes products and other car companies as well. So if you go to the next slide. As another example, this one we haven't shared broadly, but a very exciting one. We made the world's first sunglasses lenses from CO2. And these are actually featured in a documentary on climate change that was created by Rob Swan, who's a famous British explorer and environmentalist. And he is part of this film, crossed Antarctica on foot, and was describing potential climate change solutions and featured our technology. So these sunglasses and the materials from our process are now very extreme weather proven. They have actually been worn at the South Pole itself. So we look forward to creating larger production of this material so that everyone can get a pair. Next slide. On the fuel side, we've actually already produced samples of liquid fuels from CO2. We've partnered with Shell on this application. And our first customer for jet fuel, carbon neutral jet fuel, is the US Air Force. And so we'll actually be delivering fuel to them for testing this summer. And this process that we would use to make the fuel would also make fuel for marine applications or passenger transport. Next slide. So when you think about customers and partners for Opus 12, it's a really wide universe of partners. So this is just an illustration of that. You think about different attributes. So the top circle would be, do you have CO2 emissions that you want to reduce? The circle on the right would be, do you have applications for the materials that we can make from CO2? And then in the bottom circle, are you a producer of low cost, low carbon electricity? And so if you're really anywhere in these circles, it makes for an interesting partnership conversation. And we're really focused on the circle on the right for initial commercialization and pilot projects. Next slide. So just to give you a sense of how we do this and what the technology looks like, we make this analogy of what we've built as kind of like a new chip that enables a new application in existing hardware. So our core technology is a membrane that's coated with a catalyst layer. And that component can then integrate into an existing device that is usually used to do something different today. So the hardware in the background there, that system is called a water electrolyzer, and it's usually used to make green hydrogen from water. And with our new component, you can take that water electrolyzer and turn it into a CO2 electrolyzer, basically keeping everything else the same. So this gives us a really rapid scale-up pathway and limited scale-up risk because we can partner with existing manufacturers of these systems. Next slide. So the way this looks, last year we built the world's first commercial system. That's scale number 1 over there, kind of like a washing machine sized unit. That's what we're using for these different customer pilots and projects. And over the next couple of years, we'll be scaling to larger industrial scale systems. An analogy I make is scale number 4 is kind of like a solar farm. So where the farm is composed of a bunch of panels, and each panel has a number of cells. And so our core technology, the membrane, is kind of like a cell. And then scale number 4 would be like a bunch of panels combined to reach that capacity. So what we're doing is very modular. You can install a small system to start, add modules over time until you've converted all the CO2 at a particular customer site. If you go to the next slide. So we would actually integrate into existing supply chains. So you can imagine dropping one of our systems, kind of a shipping container sized unit. So this would be like scale number 3 on the previous slide, into the suppliers of these materials or fuels for these end customers. We would take some of the captured CO2 emissions, either captured from this plant or directly from the air, feed it into our unit, and then turn it right back into those useful building blocks that they're already getting today, but they'll just be from CO2 instead of from fossil fuels. And then over time, we can add more capacity. So this is like a 2022, 2023 vision that we would actually have this kind of scale and integration. Next slide. So we've been really fortunate to gather some great partners. Ocean Exchange was, I think, some of the very first outside funding that we got, so it really put us on a great pathway. Since then, we've raised funding from deep tech investors, strategic partners, mission-aligned family offices, and also have some great brand and upstream partners, as well as funding from the US Department of Energy, NASA. We do have a Mars application, so feel free to ask about that. National Science Foundation, RPE, and the California Energy Commission. So next slide. So a lot of startups talk about their total addressable market, and they're talking about dollars or number of widgets. We think about that too, about the dollar impact, but we also have a total addressable market in terms of what is the total CO2 impact of this technology? What could it be? So if you add up the total avoided emissions from switching out chemicals that are made from CO, jet fuel, and ethylene, that would add up to about 3 gigatons of emissions per year. So almost 10% of global total is the kind of the theoretical deployment just from these first 2 products that we're making. And that'd be worth about $500 billion per year. So if you go to the next slide. Our ambition is to get to at least 0.5 gigaton per year of impact, which would be enough to cancel out our partners at Shell. So if you go to the next slide. I'll leave you with this. Our first module, so the solar panel equivalent, a combination of membranes, it's about the size of a suitcase, and it converts the same amount of CO2 as 64 football fields of forest, or about 37,000 trees, but in something that you could check in with you next time you take a flight. So I look forward to hearing your questions. Please feel free to contact me at my email, and thank you for the opportunity.
Thank you, Nicholas. We appreciate it. And for anyone who's got questions, just a reminder, put them in the Q&A. We're going to invite Roger back and to join us with Nicholas. And we already have one question, Nicholas, that's from John Butler. He asks, are the fuels produced via CO2, are they emission free?
John, thanks for the question. So there will be CO2 emitted when the fuel gets burned, but that CO2 was captured from another place. So it's essentially no net new emissions. You're giving the CO2 a second life where it wouldn't have otherwise. And it keeps an equivalent amount of oil in the ground because we don't need to extract those fuels anymore.
Roger, how about you? Yeah, I have a question, and I was glad to see, Nicholas, your mention of marine fuels. You also talked about aviation fuels. Now, jet engines require a pretty high-grade type of fuel, whereas that's not the case for marine engines. Is it any easier to produce marine fuel than it is to produce jet fuel?
It's potentially easier because you might be able to have more of a blend of different fuel grades that would be compatible with the engine, whereas, yeah, there's a narrower band in the jet fuel. The kind of overall process technology is the same, but you might have fewer, purification steps, so it can make it a bit easier.
Yeah, so you could actually, potentially, it could be a cheaper product then as well for marine.
Indeed, and there's an additional benefit for marine applications, actually for any application beyond the CO2 savings, is that fuels produced by our process in combination with the downstream partners like Shell, it's much lower particulate emissions. So it actually burns much cleaner. And so for being close to ports and things, that could be an additional benefit.
And it doesn't have sulfur in it, which is another factor in our
ultra low sulfur.
We've got a question from, I'm going to jump around a little bit and not take these in order because there's one I want to come back to, but from Rick Leander, a great question. There are so few perfect answers. What are the downsides to this process and any waste in the production of the technology?
So the key to our technology is, you're right, there's no free lunch. And the part that's not free in our process is the electricity that's going in. So basically CO2 and water are very low energy molecules. And so we kind of have to put energy back into them to make it a useful product. So you want to make sure that you're using low carbon electricity so that you're not emitting more CO2 in the process than you're saving by converting the emissions. So an analogy I make is it's like an electric vehicle. If you charge your Tesla at a coal power plant, you're actually better off just buying an efficient internal combustion engine. But if you charge it in the increasingly renewable grid, it's actually got a huge impact. So similar for us. So I think the places where we will deploy our technology first will be places where you have clean, low-cost electricity.
Great. Tom Guar has a, go ahead, Roger.
Yeah, Nicholas, I guess that the really big environmental benefit from a shipping perspective is the possibility to get to carbon neutral, which is probably as good as it gets for the 50,000 vessels in the existing world fleet. But it's not the only way that you could do that. Biofuels, advanced biofuels, are, at least theoretically, they're another approach. How do you view your solutions versus biofuels?
Overall, when I think about climate-related solutions and green technologies, there is so much room for many different solutions, and our challenge is speed. So we need everybody creating solutions. I think there's definitely a place for biofuels. There's a place for CO2-based fuels. So I welcome all of it. I would say long-term and thinking about those really big scale numbers, one challenge with biofuels is ultimately you do have land use questions about where is that biomass coming from. And so I've seen some studies where they look at, you'd have to have like 14 United States worth of land to make enough fuel for, some of the larger sectors. Whereas with our CO2 based fuels, you could, have this out in the desert with a much more compact land footprint.
Yeah, I couldn't agree more with you there. I mean, this is a minimum 300 million tons per year market. So I think there's plenty of room for different solutions.
And there's a question related to that from Francois Zaveru. Is it too early to talk about what would be the estimated caloric power of a potential replacement for marine diesel oil?
So in terms of the energy content of the fuel, it's going to be fairly equivalent to a diesel, for example.
Okay. Christina Nikiforova would like to hear more about the Mars application.
All right, you got it. So the atmosphere of Mars is 95% CO2. And one of the big challenges with the Mars mission is launching all of the material that we'll need over there, whether it's rocket fuel for the trip home or 3D printable polymers to make tools or housing. And so what if you could make all of those materials in situ? Well, that's the application of our technology on Mars. You could send our unit over with a power source and then actually turn the atmosphere of Mars. They've discovered big water deposits as well. So we have everything we need to actually synthesize things there. So NASA even has a name for this whole program area, which is called ISRU, In Situ Resource Utilization. So pretty similar to what we're doing on Earth, but would enable us to be more efficient in getting material over there.
Amazing. So I have a question. I've asked you this before in another way, but I love this idea and I get excited about it. And I sort of see it as like, I want to see it as a perpetual energy machine, but I realized I know enough about physics to know that that's not possible. So my question is, you clean up exhaust out of a ship, you turn that into different kinds of fuels and products. What's the net effect? I'm not asking this well, but how often can you do that until there's nothing left of the product, or is it just continually refreshed?
Yeah, so the idea is, if you think about the way nature does things, it's always a closed cycle. So we have a water cycle on Earth or a nitrogen cycle. So what we envision is having an industrial carbon cycle where you can continue to recycle the carbon, and carbon one day could be used for marine fuel and the next day could be in your sunglasses until those are either recycled or decomposed, and then we can use that carbon again. It's not perpetual though in terms of the energy input. So the carbon gets a closed loop, but we continually put in renewable energy, which itself has a very long lifespan, since wind and solar and everything are renewable. But that's the part that kind of drives the loop to keep going, is the energy input.
Okay, a couple of technical questions. I don't think they're too technical. One from Tom Guar. What metals are used in the catalyst? How robust are they, and are they susceptible to poisoning?
So we haven't shared publicly which materials we're using, but if you look in the literature on CO2 electrolysis, many academic groups are exploring transition metal catalysts.
Okay, and then Tom McKay asks, does your analysis assume that renewable energy was used in the conversion process of CO2?
So the kind of overall, to get the maximum CO2 footprint, we assume low carbon electricity. You can have some CO2 emissions in your electricity and still have a CO2 benefit. There's just a break-even point depending on what the end application is. So for a lot of the initial CO-based chemicals, for example, the break-even point is approximately the emissions of the average US grid. So if you're at or below the US grid average, you'll have a CO2 benefit relative to conventional. And if you use renewable energy, then you can actually have carbon negative materials.
Cool. Kathy Sakas wants to know, will companies using the technology, the Opus 12 technology, necessarily use the products resulting from their own CO2? If not, what's the benefit to them other than the altruistic value of reducing emissions?
So when you think about the kind of ideal first customers, it's a place where they have CO2 emissions and they have a direct application for the outputs of our process. So it's kind of like a closed loop. It's like vertically integrated for them. You can also imagine partnerships where one partner wants to get rid of their CO2, but they don't have an application for the thing we're making. And so then there would be an offtake agreement with another partner. So that's something else we can envision. It might be something like the fuels cases, for example.
Okay. One more question, then I'm back to you, Roger. Deborah Johnson wants to know if an organization wanted to buy fuels produced from this process, how would it be identified for procurement?
So it would depend on, I would love to discuss that more in detail to figure out how we would set up that offtake agreement. It kind of, depending on industries, there's different fuel distributors. So for example, for aviation fuel, Sky Energy is one example where they have a whole network for ways of distributing those fuels to particular off-takers. And so I'm sure there's equivalents for marine applications and others. So would love to talk more about that.
Roger, back to you.
Yeah, Nicholas, one of the things that we have to think about when we're looking at the transition to a zero emission future for our industry, or what are what set of policy or other factors are going to enable or accelerate that transition? That's a very relevant question for the shipping industry, but you could ask it also, I'd like to turn around and ask it to you. For the addressable market that you've described, huge addressable market, what are the policy or other factors which are really going to enable you to, our Opus 12, to achieve its full potential?
Yeah, so the overall, we try to make a base case where we don't rely on any policy in order to enable the market. So that's kind of our base case. And then any policy will be an accelerant, as you put it. So I think there'd be two main areas. So one would be on anything that's encouraging the deployment of clean electricity. That's kind of one of the core drivers. So that'll help us and other applications that need low-cost clean electricity. So things like the investment tax credit or the production tax credit in the US for solar and wind, respectively. And then on the CO2 side, so the US, for example, has a tax credit called 45Q, where you actually would get $35 per ton CO2 if you converted it into a new product. So that exists today. If that number were higher, or if it were structured more as a direct pay rather than a tax credit, I think that would actually accelerate things. It's more usable for an early stage technology. Otherwise, you have to do partnerships to get the credits. And then Canada's come out with some very aggressive targets this week on CO2 pricing, and also many countries are putting in mandates around green fuels. So all of those things would accelerate.
Sure. Now we see a lot of the same things from sitting where we are from this vantage point, and I think what the general intention with regulation is to make the clean stuff less expensive relative to the dirty stuff. So I think the same goes with public policy. I thought I would ask for the innovators who may be watching this webinar to ask you to share a little bit about your experience of having been through Ocean Exchange, both as a student and also as a fully fledged main competition entrant. Do you want to talk about that, please?
So kind of the journey as a founder to the stage.
Well, no, I meant with Ocean, having been in Ocean Exchange, what did you learn from it? What did you, what doors did it help you open up?
Yes, so we did connect with some investors for our early stages of funding. So that was very helpful. It's all, a startup is a snowball, and you got to start rolling it. It starts small and everything accumulates. So I think an early program like Ocean Exchange, it was making those initial relevant connections. I recall also in the 2016, some of the delegates that I spoke with were able to identify some really interesting applications for our technology. And then that becomes part of the story that you're telling, both for investors and grant applications, and then going after those customers. So it's all, you're kind of building the story, building the network. So I think the program was really helpful for us getting started. And so that's why it was really meaningful for me to come back in 2019 for the full award. and to say, hey, we did what we said we were going to do, because I felt a real connection to the people who would help me so much at the beginning. So wanted to show we'd followed through.
Yeah, it was fun to have you back. Here's a question from John Butler. Nicholas, is there a potential to develop hydrogen via Opus 12 technology?
So we are essentially plugging into hydrogen technology, but our focus is to use that platform to make things other than hydrogen. So we have partners who are focused on the hydrogen side, and ours is kind of creating a new application of that technology. So I guess the short answer is yes, but that's not our focus.
All right. Here's an anonymous attendee asking a question. Would Opus 12 be open to have their potential marine fuel replacement tested by third parties to confirm the technology? If so, how could the contact be made?
Yes, and you can email me, nicholas@opus-12.com.
Great. And Anshul Tateja has a question. With no price of carbon adopted globally, what's the broader value proposition for a ship owner?
So the goal is that at large scale, with the trend in renewable energy pricing, that we can actually get close to cost parity with conventional fuel at scale. So as I was saying, the kind of carbon pricing things are an accelerant to get to that scale, but our ultimate vision is to not have this be a premium product, but just have it be the way we do things.
I think I could add
Go ahead.
Dane, is that we're starting, I mean, if it's close to price parity, as you're saying, Nicholas, I think that we're starting to see some signals from the market that there is interest from some of the industry's customers, to pay a premium for a service which is carbon neutral. It's very cost sensitive, but if it's just a marginal difference, yeah, I think that we're arriving at that stage now where it's viable. Sorry, Dane.
No, that's okay. We've got one question, then I'm going to hand back to Millie, and then one question for afterwards. Is water consumption for this process per pound of CO2 processed, is it similar to that for biofuel generation?
Great question. So it actually consumes a lot less water than conventional petrochemical production. So I'm not as familiar with the numbers for biofuel production. But for example, when we make CO, it's actually net water neutral. We put in water as an input, we actually create an equal amount as an output, and it's very clean water. And then if you look at something like ethylene, where we do use the water to make the hydrogen and ethylene, if you compare that to a big petrochemical plant that's at 1,000 degrees, and all of the upstream fossil fuel recovery, transportation, it's nothing relative to the way we're doing it today. So we see the water impact as a significant benefit as well. I'll also say you asked me about the policy things. One thing that is critical that I didn't mention is thinking earlier stage, and something that's been key for us is government R&D funding. So, I mean, that funded my co-founder's PhD and postdoc work for this technology. There's the Small Business Innovation Research, so SBIR funding, that all of the major government agencies in the US have to fund startups doing new breakthrough technologies to get them to the point where they're ready for private sector investment and working with customers, and then larger scale demonstration grants. That is absolutely critical, and it is what enables us to stay as an innovation leader. So would absolutely encourage us to all keep funding government R&D. It's important.
Great, Nicholas, thank you. And Roger, thank you. Millie, I'm going to hand back to you, and we've got one question for afterwards that we'll go back to.
Okay, Alice, if you can go back to the slides, run the slides. Wow, Dane, I think we ended the year on a bang. A big bang.
Great one.
Thank you, Nicholas and Roger. And I want to thank Dane. Dane is our MC and a lot more than that, a great friend of Ocean Exchange for our event. We plan to have our event in 2021. It will be in Fort Lauderdale. The dates tentatively, but I mark this down, October 24, 25, and 26, and watch for details early in the year about that. Next slide. We do plan to continue our webcast next year. We started this because of the pandemic, and it's been a big hit. We want to keep it going. Also watch for news about this. We plan to do this in collaboration with a partner, a big entity whose name most of you will recognize. So watch for that news. Next slide. Again, thanks to our sponsors. Contact me, that's my email address. Next slide. And again, thanks to everyone. Thanks again to Alice. This is number 9 in our series. If you're curious about the other ones, there's a link right there. If you know, take a picture of that slide with your phone, or if you don't have your phone handy, email me and I'll send you the link. Thanks to everyone. Have a great, healthy holiday season, and we appreciate your interest in what we do. I'll turn it back to you, Dane.
All right, thanks everybody. And if you want to stay on, we're going to just go through a couple more questions here. This is an interesting question, Nicholas. It's from Christina Nikiforova, who says, concrete has been making the news as a big emissions offender. Have you considered sequestering carbon into low carbon concrete with Opus 12 technology?
So there are startups who are focused directly on concrete and cement applications. Our technology, there's a couple of chemicals that are used in the cement production process that we could make from CO2, and then that would effectively store the CO2 in the concrete. So we have compatibility, but it wouldn't be that there's not going to be Opus 12 cement. It would be kind of cement with reduced footprint thanks to Opus 12.
So I've got a question. Roger and I this year have spent some time talking about what we call at-berth emissions. When a ship is in port, tied up at the dock, it still has 6 or 7 different engines that are running to power everything that happens on a ship when it's at dock, and looking for ways to solve that problem. Trying to think of a ship either at dock or going across the ocean, with your technology, diverting the exhaust and capturing all the CO2 out of it. Trying to imagine how that would. Is that a workable process? I see that you can do it in a land-based thing. Is it something that could work on a ship?
So I guess in principle, yes, but it's much more efficient to do it all on land and kind of have like one big site where we're taking everything and then we're like making the clean fuels that then go out into the ocean. So the net emissions aren't there. Just because then you have to add a lot of onboard equipment for capture and conversion and the energy to do our process. So that's why we do it on land.
Yeah.
And that's really
Go ahead,
Dane,
Roger.
to add from the shipping side of that, I mean, if you could do that, you also have probably got a solution to the original problem anyway, because it's going to take an amount of energy to run the system. And if you had that renewable energy on a ship, available on a ship, we probably wouldn't be having the conversation in the first place. So I think on the at berth, there is some potential there. It's not terribly easy to capture those emissions on some vessel types, but it's, as I keep often saying, this is a big varied industry. Just because it mightn't be easy for our vessels, could be for others.
Yeah. Interesting. If anyone else has any other questions, that's all the questions we've got. Type them in and we'll wait.
Yeah, I see John Butler had a question to me on hydrogen propulsion for shipping, and that goes back to what I just said a moment ago. I think for certain types of shipping, hydrogen as pure hydrogen can be viable for short sea in particular. That's vessels, they're operating across short distances where they're regularly back at the same replenishment point. For deep sea shipping, it doesn't look very good because the energy density is a real problem. You'd have nowhere to put the cargo basically once you'd finished building tanks big enough to give the vessel the range it would need. There's also the engineering involved with something on that scale that's minus 250 degrees. That's a huge challenge too. But ammonia, which is a hydrogen intensive fuel, that's a better prospect, but it's not perfect either because of course it's flammable and caustic. So it's maybe one of the least bad possible solutions for the industry.
All right. Well, thank you, everybody. We've had a lot of people have stayed on for this, and I think this is, as Millie said, this is we rocked on this one. This was great. We've got some comments. Well done to everybody. So thank you, everybody, for listening. Thank you for being here. Nicholas and Roger, thank you so much, and Millie, thank you for running Ocean Exchange.
Thank you
Talk to you
all, and
soon.
watch for a link on our website. We capture this and send the link to others who may not have had a chance to hear it.